Hi, welcome to Feature Friday. It's a pretty big Friday because we've just released a very large release. It's January 31st. This is release 1.193 for those counting. And CAM has obviously come out today, but also a really, really important one for sheet metal users, which is the sheet metal form feature. And there's a really excellent video on the What's New forum page. It's well worth spending those 3.5 minutes with this video, taking through some of the paces. But I want to do a little bit of a deeper dive and maybe touch on a few more things come up along the way and delve deeply into that. So really at the high level, you can now find a sheet metal form feature in the sheet metal toolbar. Here it is. And it's very easy to use. You choose from the form you want to use, and there's a few different ways you can use it. You can go to the Onshape library, and in the Onshape library there are a built-in number of them, maybe 9 or so here. A few different lances, a couple of different embossers for circles, and a louver or two. All right. You can also create your own libraries, and we'll get to that. And this is what I've been doing this evening. I'm creating my own library here, and we'll look at that as well. You can also build one-offs. If you have something in your own document, you can choose your current document, and if you've been creating correctly the sheet metal form, which again we'll get to in a second, how you do that, then you can use it from here. But the default way, and the first way you're probably going to do, is the Onshape library. And this is the one that's going to pop up in front of you straight away. What you do is you just choose a location from it. And if you have a mate connector already, then you would just pick it, or a sketch point, or you'd pick it. But you can also create one implicitly. Now, we cannot create a form feature that runs off the side of the wall of a sheet metal part. Obviously, you need a sheet metal model open and active. What you can do then is rotate it and move it a little bit. All right, so we're going to move it in Y, I think, negative Y, until it jumps onto the model, and there is our form. Okay, so that's one thing you have to know. The other ones on here this is the library that comes with in the Onshape library right now. As I said, there's a couple of louvers, some slots, there's a circular knockout here, and a couple of lances. Now, when you look at the flat, you'll see that you have a representation of the form's shape using these sketches. And I think Neil goes through that in the video of how you have some options to export that. When you create a DXF export, you can choose to show the center punch positions and the actual sketch lines of the form. So that's some options in there. But yeah, so you can just move this thing around, and you'll see if I keep going in that negative Y direction a little bit more, maybe a lot more, simultaneously we're seeing the update here in the flat. So that's pretty nice. So explore the library, and then you're probably going to be intrigued, like all of us were, how can I create my own? Right. So I have been doing that this afternoon and this evening, and here is what I've come up with. Now, some of these are shapes that I've used in the past in various different systems and in various different applications, but I've sort of consolidated them all into my own library in a bunch of different louvers, again, some different lances, and some more aerospace specific things that we'll get to in a minute. And also there is no need for it to always add material like in here. You can actually create punches that only cut material, and they're going to be useful for a number of things as well. So how do you create these form features? What you need to do is you need to create a part studio, and in that part studio there's a few prerequisites. One of them is a part which you're going to designate as the removal part, kind of the tool which is effectively going to boolean out or remove material from your sheet metal part. And then you can optionally, depending on the shape or the style of sheet metal form, you have another part which is the bit that's going to get added in. So you've got two parts. In this case, a removal part and a adding part. Now that is the only geometry you need. In fact, you could get away with just one part, the removal part, if for just a punch. The next thing you definitely do need is a configuration variable called thickness. This is a strict requirement, and is the definition has to be valid at least from 0.01 millimeters onwards. So set that as your minimum value for the thickness. Now, when you create a variable, the name that the variable is defined under is when you create it. So if we create something here, say blah, right, you'll see it creates that name there, like that. Now, it is possible to come back at any time and change the display name, new name, like this, but the variable is actually still called blah. All right, it's good to know. You can actually change that. If you look at the triple dot here and go edit the feature script ID, that's what this is. You can see here, you can actually change that to something else. It's got to be a valid variable name, so no spaces or anything crazy like that. And when you do that, it'll just warn you that it's going to break anything that was referring to that, but that's fine. So all that is going to just be deleted. You need to create something called thickness with an underscore, with a lowercase t. Change it later on, do what you need. Now, I'm going to use all sorts of other ones in order to make this a parametrically updatable feature. You don't have to do that. If there's just one size for your form, then you don't need it other than thickness. You don't have to. But it's probably a good idea to make this thing parametric so that you can change the diameter, change the angle, let's do things like this, and have a really nice flexible feature. Now, we'll get to standard sizes in a minute. But so far, the only thing you need is this configuration variable. The next thing you definitely need is a sketch, which it's going to represent the shape that you see in the flat of the form feature. So typically, if you have one already, which is convenient, from the top view, which I don't, you just can create another one, right, and just use some edges that are convenient for that sketch, which is what I've done here. And the last thing you do is create a tag, and a tag is the thing that designates it as a form feature. You'll see the tag up here. And previously, the tag was really just for the frame profile library, but now you can see there's the frame profile library and form library. Within the tag, there's a little bit of information, not much, that you need to do. You need to tell it what is the part that's going to add, which is the gray one, to the sheet metal model. What is the part that's going to remove, which is this blue one from the sheet metal model. And then you also need to tell it what the sketch is, so the sketch 3, and you also need a mate connector or reference coordinate, show where the location of the form is going to be placed when you choose it on your sheet metal model. Now, if you model everything carefully at the origin, like I have actually here, so I should use my space mouse. I've modeled everything at the origin, so where this thing would line up and be applied to the sheet metal model is the origin, and it will assume that. But if you want to put it somewhere else, you can actually create a mate connector and choose that in the tag. I kind of did the mate connector anyway, and that's kind of just a habit now. So that is all you really need to do. And now this is declared as a sheet metal form. You can either process it through the library mechanism, which Neil has already showed, and there's documentation on that, or you can just leave it as a part studio here and refer to it in the normal ways. Now, I'd like to create these form features kind of in a very physical looking thing, like an actual piece of die and a tool set that looks a little bit like something you might buy, right? And so that's the way I model them, as these big pieces of solid model like that. And then it's convenient because then I can see very easily the surfaces or the faces here that I'm actually just going to thicken. And I use a thicken feature, you can see it there, to then offset that or thicken it by the amount which is the thickness. So of course, that is where I used my configuration variable. You can see here, thickness, which is that configuration variable. Interesting thing here you'll see is that and this is totally my own choice, and it's not advocating you do or do not do this, but I'm using some coloring on faces that are actually slicing and going to leave exposed faces sliced in the sheet metal model. You can see that red one there. If we go back to where this was being used, I think it's this one here, you'll see that it actually does leave that red face on your sheet metal part as well. It's very convenient for me, I think, because it just shows me, it just definitively shows you where the bare metal cutting is occurring. Now, you don't have to do that. It's completely arbitrary. But it's nice to know that you can. Right. Okay, so that is one form of modeling in a model the tool, model the form of it, and then thicken and do some other techniques. That's what I did for this. Now, there's another set of tools here, which is an aircraft punch and flare, which looks like this. Here's the sort of cross-section of what you're trying to achieve. It's just a 35-degree flare. There's the punch out is here, which is the size, and there's a 1/8 inch height here. So it's a pretty simple piece of geometry. And they come in sizes from 1 inch to 6 inches with a few intermediate sizes like that. So looking at how you create that, this is a really, really easy one. You didn't have to do it in the same way that I did that other one. What I did here was a sketch which looks a lot like this. And I added it. You can see where these variables are. The 35 degrees is fixed. It's always that. And there's always this 1/8 inch drop height here. The other variables that have been applied are to do with the thickness. So I'm just, applying the thickness of the material here and then twice the thickness on that radius. There you go. That is where that. Now the diameter of the punch out is another configuration. You can see over here. Now, you don't have to use configuration variables for the other sizes. The only configuration variable you absolutely need is the thickness, like that one. As again, you need this one. All right. Not going to work otherwise. But you can use an input table for these other ones here. So you can see here that this only comes in certain sizes. You can't just type in your own value and hope to go to this website and buy it. It only comes in these sizes here. So it makes sense to do it in normal configuration ways that you've been using in Onshape for a long, long time. And you see here, I can just choose from these different sizes and make sure that this form tool is updating predictably. So this piece of thing, this is the add material again. Again, we have a remove piece of geometry, which is very, very simple in this case because it's just a circular. And then the add bit goes in here. And then we do the standard method where we choose the part to add, the part to remove, the sketch to show on the flat, and then the make connector for it again. And now we have our tool. So if we wanted to show how you use that now, I've got this blank piece of sheet metal model started. It's an active model. I'm going to then use my form tool and choose, instead of using one of this Onshape standard library forms, I'm going to go to this current document. You can see here there's only one available for me in this document. That's the one we've just been talking about. So you choose it, and then you choose where you want to locate it. And you can actually locate it in multiple places at the same time, like this. These could be sketch points, they could be implicit make connectors you'd create on the fly, or they could be these actual make connectors which were in the part. If you want to flip the direction, you just use the flip. You can see here, and if we come in here, flip it back again, and we've used the form. All right. So if we edit that, we can just click on the shape and choose one of the other sizes, maybe the 1 inch. hit regenerate there, and now we've got our 1 inch ones there. So we'll cancel out of that because we like that shape. And we're done. We've achieved what we needed to do. And if we have a look at the flat, of course, we'll see the nice representation of the form outlines and the punch centers for that. So that's how it works. There was one other one that I was wanting to show you up here. So typically these form features, as the name suggests, are forming the material into a new shape, like stretching it and doing these rectangular offsets or circular offsets or louvers and whatever else. But I've probably mentioned that you don't have to add material like this. You can actually just punch it out as using the remove part of the tool and do some fun things here. So let's have a look at this one here. This is the obviously a logo that you might be familiar with. And it is in my library now, so I'm going to my form library. And I've actually separated it into 2 different classes: forms, which are all these things, and punches, which are these other ones. And the punch is easily modifiable. You can change the... it's parametric, of course it has to be. And you can put that in there like that. So the other ones here, just quickly, the other punches. This one is another parametric one, and it's not surprisingly called a polygon, where you can change the number of sides that you would like in your polygon. And here we go again. You can change the flat to flat distance, in this case, and the number of sides. You can put all sorts of expressions to clamp values when you do these types of things, when you set them up in your part studios for the form feature reference. And I have done some of these things to guard you from being able to create invalid or strange shapes. In other cases, like this one here, it only is valid for certain thicknesses. So we can do all sorts of things like that. Now, the last one here is a punch, which is similar to this one, where it looks interesting. It's actually doing multiple holes at the same time. Again, it's called spotty here, and I can control the gap of this one. I can make that a wider gap, and obviously make these holes a little bit smaller. If you if you want to do that, you actually, the only thing that you have to do, which is kind of special, and not hard, is you need to make a single body out of the punch, so that if you have these 7 different bodies when you first create this punch, you're going to have to create one body which kind of connects them all together, and it's kind of trivial, but you do need to do that. You can only have a single removal body. And speaking of removal, you don't have to remove the whole thickness of material. You can cut a groove. This is not necessarily a manufacturable, a perfect example, but it's a nice fun one. You don't have to remove all the material as you go, as you create this removal. So let's have a look at this one. Now this one is interesting because I've made it parametric, not just in its thickness and height and the depth of the cut. And this is one of these ones where I can change the values, but if you can hear me hitting the button, the down arrow, I can't make it any smaller because I've just limited it, and you can't make it, you can't make it any bigger than that, because it is, you don't want to create multiple floating bodies. That's not manufacturable for sure. So the way that this one works is kind of interesting as well, because you can just type in a new string. Like if you wanted to type in 1.193, because that's the release where this magic is happening, it's parameterized the string that you go in, and it's cutting that into the tool. So it's modifying the tool that's coming from the library. So that's pretty cool. All right, so I'll show you what that tool looks like now. So here's the source of that tool. It's a pretty simple one. There's only, all of these take very, very few features. The first feature, of course, is going to be the sketch. And like all of these, I've created a configuration variable for thickness, and need that one. then I've created whatever other configuration variables I felt I needed. So I wanted this text string, which I've called hash text, and I've created a depth, which is actually going to be a number, a real number, kind of like a percentage of the depth that I'm going to cut, and then the height of the actual text. So if we edit this sketch, you'll see that I've used that variable height for, it's handy as you just roll over the mouse, you can see the expression being used, just height. The other thing I have done in here, which is interesting, is if I edit the actual text, you'll see something kind of special and crazy you may not have come across in the past. And that is, you can use a variable, which is this one, to actually define the string that is going to go into this text in the sketch. All right, let me back out of that and explain that in another way. So if I create another sketch just to show you what's going on here. Normally, you do this. You type in and you get your text, which is actually going to go into the feature. What not everyone realizes, it's super powerful. If you right-click, you can click on this Convert to Expression. So what is going to go into this box now is actually an expression. And expressions in Onshape are incredibly powerful because you can access variables, you can access math functions, string functions, all sorts of things, and do really logical things in here. So the easiest one I'm going to do is access by the hash representation of the text. So if I do that, then it's actually going to put in whatever the value of this text string is as the text in this sketch. And you'll see that if I change this text string to say to 1, 2, 3, that is updating. Now I've done it twice because there's 2 sketches in there now, so I don't need both of them. But I think you can see it's going to be an incredibly powerful thing here because I could just type the the 1.193 or whatever I want. So I just leave it as 1, 2, 3 for the second here, because then I'm going to extrude that, and I'm going to extrude it by no prizes here, by the thickness of the sheet metal multiplied by this depth function or this depth factor that is over here. So that gives me how much material I'm going to cut out of the sheet metal. Now what we do need on here is also perhaps a mate connector to show where we're going to place it. I want to do this in the centered, I've just created a in the center line here. And we couldn't use this, sorry. We couldn't use this because there are 3 separate bodies and we only can use one body when we do a removal tool. So what I did do was the obvious, which is just, block it over the top and create a single body of it. Now, it also happens to be, something that might look like an actual stamp, right? And you could go crazy. You could build like a handle or some tooling that would actually, how you would insert this into the tool holder. Go crazy. The only thing that's actually going to matter is the bit that's below this mate connector, which is going to actually boolean out of or cut out of the sheet metal part. Now, just to help myself out, because the thumbnail was going to look a little strange from this angle, I did extrude the text through again the other side, but this is again purely aesthetic. The only stuff that matters is the one that's below the mate connector down here, and of course it's in this reverse text. Right, and the last thing, of course, let's go and check that we did do this configuration variable. I can't emphasize enough, if you haven't done this, it's not going to work unless you have the configuration variable called thickness. You can make sure that you flex and exercise the parametricness, the parametricity, or however you want to call this, to see that your feature is updating and it's going to behave nicely. I have used a trick to color all of the faces, again, so that when we look at its use, it's going to be coloring the faces on the other side as well. That's just a really interesting side effect. And the way that you color these is you look at the feature that created that extrusion, right-click, and say, there's a feature appearance. any feature that creates a body like this has a thing that says add appearance to feature. And if we do that, whatever the geometry was added by that feature would be colored in this special way. And I've done it in red for the bit that pokes out and cuts into the tool. Right, so then that's how it works, right? Then you just do the tag as before. We don't have a part to add. We don't need to put anything in there. We're just doing the remove, and then we're done. So we just clean that up, and then that's what we've been using over here. So now you can see in the flat again. Oops, if we turn onto that on the side there. Now, you would probably do different things in sort of different grooves. Maybe you've got some special lines or dotted line, dashed lines or something like that you might want to put in here as well. But the point is that this is an incredibly flexible, powerful feature now that's been added to the sheet metal environment in the past studios of Onshape. So I'm looking forward to seeing everyone getting good value out of this and hearing about all the successes. See you on the forum.